Folks, this is 10:30 and it's the last lecture of week number 4. So we started the subject of assembly problems with you last, I think it was on Tuesday at 4 p.m. Okay, so we already did one problem, and this is the second one that I'm going to be doing. It is a shrink fit problem where you have for example, a brass ring, the yellow one, that has a slightly bigger than that hole, which is made out of steel, and you want to insert that brass ring in that steel hole. Now, this problem is called shrink fit, or pressure fit, or interference fit. These are all meaning the same thing. Okay. My question for you is, can somebody tell me how you can do that? How you can put that thing that's yellow, which is bigger than that hole, inside of that hole securely, besides just hammering it? So can somebody tell me what would you suggest? Can you say it? You unmute your mic, please.
Heat up the gray part and then put the yellow part in the hole.
I'm sorry, say that again? Say that again?
You heat up the gray part and then you put the yellow part in the hole.
Yes, that is correct. That is correct. That's the process of the most effective way of doing it. I don't think there's any other way. I mean, obviously you can cool down the brass and then do the same thing. But you're right. Now note a couple of things you should keep in mind, and that is if when you do that, of course, the bronze is going to get shrunk, because that steel ring is going to cool down, and when it cools down, it presses on the brass, so the brass is going to get compressed, and the steel ring is actually going to get fatter, because you put something that's bigger than that hole in it. So there is going to be a stress develop, a pressure develop between the brass and the steel, and that is exactly what you need, because that pressure causes friction. Okay, because let me remind you that the friction force was the normal force times the friction coefficient. This is your statics class. Okay, so that pressure multiplied, think about it as multiplied by friction coefficient, obviously you have to convert it to force, is going to give you friction, and that prevents this thing from just loosely running around in that the brass running around in the hole. Now the only problem is, if it's too much pressure, then of course it may yield the ring, the steel ring, or it may yield the brass ring, whatever. So too much pressure is not good. Too little pressure makes a loose fit, and things are not going to work out. Okay. All right. This kind of a problem, believe it or not, was done about 200 years ago by our predecessors without, or forefathers, without any computers. I mean, a lot of these developments, fundamental developments, were made 200 years ago without any computers. Okay, by people like Euler, Lagrange, Kirchhoff, etc. But anyway, they worked it out for simple problems. Simple problem means linear elastic material, and assuming that it's a thin disk to be shrink fitted inside of the thin ring, and they came out with the expression for the contact pressure here. And in it, of course, you have the material property, Young's modulus of the steel and Young's modulus of the brass, and Poisson ratio. And these are dimensions, ABC, or the radii, different radii of these two rings. And on the top, you have something called radial interference. For example, in my case, if this diameter is 4.002, and it's supposed to be 4, the diametral interference is 0.002, the difference of the two. And half of that is called the radial interference. Now, needless to say, if the smaller the radial interference, the smaller p, obviously, there are drawbacks for small p. They don't fit together loose. They fit together loosely, basically. The larger delta radial interference, the larger p. Dangers of too much pressure, yielding, etc. So we're going to solve this problem. And you have to do this thing as an assembly. You have no other choice. Okay. Before we do that, are there any questions? Okay. All right. So right away, we start with a product file, because I assume my strategy for simple problems, and all the problems that we are doing are simple, okay, is to make things on the fly. So in real life, these parts are made in different places in North America or different places in the world, and are, you know, shipped together to one place for assembly purposes, etc. So the drawings also, or the designs also, may have been done in different parts of the world. Therefore, they send you, as an engineer, they send you the parts, and then, or part files, let's say, and you're supposed to put it together. Here we're going to assume that we're going to make the parts exactly as we go along. Okay. Now, immediately this product I'm going to save. So file, save management, and there's going to be save as, and there's going to be a desktop, and I'm going to create a folder. I'll call it the lecture section 2, your lecture section 2, lecture section 2, and today is June 4. Okay. This product is going to go into that folder, and I'm going to give it a meaningful name. Student ID number 1, 2, 3, 4, 5, 6, 7, 8, 9. This week you're still ranking. And I'm going to call it problem 1. Let's pretend that we have to do this thing for problem 1 of our test. Okay? So obviously this is product, which is associated with problem number 1. And we say okay. And we say okay. All right. So now we're going to insert our first part. Insert new part, because I did not make this thing. New part in there. And, you know, I'm going to rename this part. Now, if I don't do that here, it is okay, no problem. You can do that through file save management, but you'll see that doing it this way is a lot easier. Right click, properties. There is your product. The name of the product, I'm going to call it 1, 2, 3, 4, 5, 6, 7, 8, 9, dash. Your last name is Rankin. And this is the steel. This is the steel. How about ring? Outer ring, okay? Steel ring, okay? Now, I'm going to copy this. And I'm going to put it up there. Paste it. Because, you know, a part has a part name and an instance name. Actually, CATIA doesn't call it part name, it's called part number, okay? And this instance name may not be important for us in the first 7 weeks of the course, but it's critical when we go to the last 4 weeks or 5 weeks of the course, okay? But I'll use it. Now, the nice thing is that at this level, I'm at assembly, right there. You see that? Right there. At this level, assembly, if I click on the floppy, what happens is that the product already, I gave it the correct name and everything. But if you look at that folder, the part is also saved under that correct name. Okay, so let's see now. Let me get rid of this. There is lecture section 2. Remember, I started with my product. I gave it that name. But because I renamed it using the properties, the part, the steel ring also, I don't have to go to file save management and say save that, blah, 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 etc. Okay? All right, good. Now, let's go back and make it. We haven't done anything. We just inserted that thing. Now you have to go make it. So you double click on this line, which will send you into part design. We are in assembly design right now. automatically send you to part design. And now we're going to make it. So on that horizontal plane, I will sketch. What I will do is the ring, a ringish thing, and then pad it. You can also do a rectangle and then shaft it. It's up to you. It really doesn't matter. But I will do it the way I just told you. So I'm going to make a ring. And there are zillions of different ways of doing these things. You do it your own way. You come up with the thing that we want, and we're perfectly happy with it. Okay, there we are. Now let's draw our lines. One from here. I'll clean it up in a minute. Okay, and then another line from there to there. I'm doing a lot of extra unnecessary things here. I understand that. Quick trim it, double click, get rid of this, get rid of that, get rid of this. Perfect. Now we're going to make some dimensions. So this outer one, this outer radius is 2.5 inches. 2.5. Okay. Okay. And this inner one is 2. Let's see, I screwed up. 2. Oops. I didn't screw up. It's just that it's cause of confusion and panic. Okay. So 2 inside, 2.5 outside, and I'm going to exit. Oh, I forgot to do something. This sector, let me go back to the drawing here. If this problem was given to you, you will be told to use as many planes of symmetry as necessary. Now, in this case, you look at this, you can cut it in the middle, halfway, top and the bottom. You can cut. That's one plane of symmetry. You can also cut any sector, any 45, 30, etc. Now, I will not leave it to you. I will not tell you about the middle one. The middle one you have to know. You have to see it and say, oh, middle is a plane of symmetry, top and the bottom are going to be the same. But so that we don't have to mark 10 different versions of this, we're going to say, oh, take 80-degree sector or 45-degree sector. This is a hint that you know the one plane of symmetry is like that. Take a sector. Okay, so I'm going to take 45 degrees. That means that I need this dimension, this angle from here to here. I'll make it 45. 45. Excellent. Exit. Pad it by half the height, because that is the plane of symmetry. So if the whole height was 1, I'm going to pad it by 0.5, and there we are. Now, because these parts are made of different materials, I can't put everything on product, so I'm going to put it on the parts one by one. So this is the part that I just made, and it's going to be made out of steel. So metal tab, steel on that part, and then say OK. And we are perfectly happy with the first part that we made. Now we're going to insert the second part. Insert new part. Oops. Well, wait a minute. Why am I not getting there? Insert. Didn't I say insert new part? Right? Insert new part. I don't see a new part here. What's going on? Help me. So why am I not getting the thing that I want?
Showing part design?
Yeah, that's right. You have to be in assembly design, absolutely. So you either double click here to get thrown into assembly design, or if your preferred way of doing it is a different way of getting into there, go ahead, do it. You're right. Insert new part, because you're going to make it. Always say no. It's a good idea to read that thing every once in a while too. And we're going to rename it, right? Right click, properties. And the good thing is that thingy, that paste is still there. So I'm going to say paste. Okay, so this is going to be the brass ring, right? Brass. This is the instance, and the actual part name is down here. Brass, paste. I'm going to change that to brass. The nice thing is that as soon as I click on the floppy, this is going to be saved with that name as a file. See? Let me do that. Click on the floppy. Go check your folder. You see? This was the product. This was the steering. and this is the brass ring. Now, I don't care. You don't want to do it like this, go do it any way you want. Just make sure you submit the right stuff to the right folder on the test. Okay. Now we're going to make it the same story on that horizontal plane. I will sketch, and there may be easier ways of doing it. I'm sure there are easier ways. Some of you can do this thing a lot better than I do. So I'm going to do it like that. Once again, like this. Okay, and doing it again, like that. As I said, this is moronic, some of it. So this time I'm going to go from here to here instead of making and trimming it. But the other line I have to do here. Now, this is a little bit, you got to be careful because I want to make sure that I start at the origin. In other words, my line is radial. And I strongly suggest for you to, if you have the time, to watch the earlier video that I did. Oh no, I'm sorry, that's not going to be on. You don't have access to that though. I did it for section 1, and if this is not correctly going through the origin, you have to fix it later on. No, never mind. Okay, so let's double click on this. We're going to clean this. We're going to clean that. Oops, wait a minute. Try it again. We're going to get rid of this, and we're going to get rid of that, and then we're going to get rid of this. Okay, very good. Now let's put some dimensions. First of all, between this line and that line, 45 degrees. Yeah, 45. Oh my God, I think this is going to run into the same problem. That's okay. We'll fix it. No problem. Okay, so dimensions. This one is a little bit bigger than 2.001. That's the brass. A little bit bigger. And if you zoom in, you see that, oh, it's a little bit to the right of that guy. You see this? You see this? You see? This was the steel. This is the brass. Okay, very good. All right. And the inside radius is, I think, 1. Excellent. Okay. All right. You see that? These are not the same thingies. We're going to fix that. So I ran into the same problem with the first class, so I had to fix it. Okay. So when you pad this by 0.5, you see? And this has to do with my sketch. So let's go and see which one do I have to fix. Do I have to do the first one or do I have to do the second one? Let me go to the first one and see what's going on there. Okay. You see this line? I thought that it was going to go through there, but it doesn't. So let's try it now. So where is that? This line. Control that center. Okay. Make it coincident. Okay, very good. And it sure looks the other one is also a problem. So exit this. Go to the other sketch. Go to the other sketch. And probably it's the same story. This line no longer goes through that. That's my guess. I don't know. Control that point and coincident. Yeah. Okay. Very good. I don't have a magic rule. Things like this happen because I thought it was okay, but well, whatever. Now, let me change the color of this. The only thing is that I don't want to change it to yellow because when I change it to yellow, when you go to the sketch, the colors become black. You know, we'll make it something else. How about that? So properties, where's that? Properties, under graphics, let me make it, I don't know. Oh, wait, this. Okay, very good. When I said this thing turns, the colors turn black, if you go to the sketch, well, actually here it also changes the color. Okay, well, I guess either way. These are ordinarily either green or white, etc. But when you change the color of the part, it looks like this is what happens. It's fine. We don't need it. Okay, good. Now go to the assembly level. Brass, right? We have to apply brass to this. We have to be in part. So apply material, brass on this part. We say okay. Now we go to the assembly. We save everything. Okay. Now, as far as finite element goes, you don't have to apply any constraints here, these assembly constraints. However, if for some reason you need to move these apart and you don't have any assembly constraints, you're pretty much stuck. Okay? For example, let's try it. If I go and my favorite way of moving things is move and manipulate, okay? So let's say that I move that guy. Okay. Oh, come on. Okay, like that. And then I have to do, I don't know, this, like this. We are pretty much stuck. We're pretty much stuck. Okay? So, I'm going to put assembly constraint. Now, let me undo these. I don't like this last one that I did. So let me move them apart. So let me move this thing move this thing up. Okay, very good. When you put assembly constraints, it's a good idea to anchor something. Anchor something. So I'm going to click and I'm going to anchor that. This anchor, whatever you do with these guys, has nothing to do with finite elements. Because when I done this problem until the end, when I got the displacements and things like that, this guy moved. And somebody said, well, wait a minute, didn't you anchor that? Why is it moving? That anchor, this anchor that you put here has nothing to do with finite element restraint. Nothing. Okay? It's just for assembly purposes. Okay, now let's put this thing, the axis of this, the axis of that, and the axis of this coincident. Already, because I just translated up, it's already updated, okay? And coincidence between this face and that face. And once again, because they're already, I just translated this, there's nothing to update. However, when I say coincidence between top face of this and top face of that, notice that this comes on, because right now they're not coincident, you update. If you ever have to move these things around, and I'll do it for you right now, if I ever have to move these things around, I do some crazy, stuff like that, and like this, and then I update, they go back they were. Okay, so let's save everything. Before we go to the assembly, before to go to finite element module, are there any questions? Okay. All right, by the way, I don't know whether I saved or not. So yeah, I did save. So now we're going to go to generative structure analysis, fancy way of saying finite element module. Static analysis, that's all we do in this course. Now, notice that there's some stuff here that I don't need to see. Like these things happen because of the assembly constraints. I don't want to see them. The easiest way is to go there and say, don't show me hide the constraints. Don't show me that stuff. And let me change the rendering here. There we are. So Katia saw two parts and solid parts, two solid parts, and immediately it meshed that for you. I don't need this anymore. So notice that it created two meshes for you. One for the steel ring, one for the brass. And by the way, remember, when it does it for you automatically, it also creates the 3D properties automatically. You don't have to worry about this. Okay. Now, the type of element that it uses is probably whatever I used last. So I did this problem with the 830 class, so probably I said parabolic. Let's see now. I said parabolic. Okay, size is okay for me. I don't have a problem with that. And same thing with this one. This is the brass ring, the inside one. I also changed it to parabolic earlier this morning, and it still remembers that. And these are the sizes that does by default, CATIA does the size of the element based on the size of the part. If this part was 2 mile long, it'll make a big element for you. If this part was very small, it makes element very small. So you have a control over these, and whatever it gives you for default, you may not like it, and you will change it. Now, one more thing. Notice that there is very little action going on here and there, but we know there is a lot of action going between at the interface. So, well, first of all, you have to realize that the stress from the brass to the steel is not going to be continuous because you have different material properties. So it could be that here is blue, right next to it is red. There is no gradual change because this material has sudden discontinuity in the properties. Now, this being the case, it gives you a message that basically it goes from blue to red very fast, immediately. And we know what happens when colors change very fast. Not immediately, very fast. You need a fine mesh in that area, okay? And now here it drops completely. What? Okay, you need a fine mesh there. Now, how did we do local mesh refinement? Now, I'm going to ask you this on the test. And if you don't do it, okay, you lose so many points, part marks on it. But before, we have done it. This is not the first time we are doing this thing. Look at the Model Manager toolbar right here with the traffic light. The second one on the right, it says local mesh size. Now remember that you may not see that, you may see this, but you open it up, you see local mesh size. Now before, when we clicked on this, see that when I clicked it, before a dialog box opened up and say, oh, where do you want to do that? How much? It didn't happen this time. And if you can make sense out of the comment that they have down here, this is the prompt area, it says select a set to create the local mesh size entity. You know what it's telling you? It says, hey, my friend, you've got 2 elements here. Which one do you want to refine? It's waiting for you to tell it. Is it this one or is it that one? In the past, we had a single part. When there was a single part, there was only one line of these guys, and there was no confusion. But here it says which one. So let's do both of them. I'll start with the first one. You see this? I'll start with the ring, steel ring. Click, click. And the dialog box that you got before opens up. It says where. Now tell me where. So I'm going to hide this brass piece, and I'm going to select this surface. Notice it puts something tiny there. And that tiny has to do with whatever I put in there before. If you want it smaller, make it smaller. If you want it bigger, but you control this at the interface. Okay, now do it again on the other side. It says which one? Oh, the second one that goes with the brass. Where? Well, I've got to go and get that thing that I hid. It's that face of it. And I say, okay, let me bring this thing in the front so that you can see it. And it also put a tiny little thingy there. Now you can't see it because of the rendering. If I change this thing to wireframe, you're going to be able to see both of those. See that? One of them was for steel, the other one was for the brass. Okay, but you couldn't see it if the rendering was with a, I don't know, shading, stuff like that. Okay, very good. Now, before we run into trouble, we're going to save our analysis file. So we go to File, Save Management. Notice that our product is open. Our part, steel part is open, brass part is open, and there's the analysis. Save as in the correct folder, lecture section 2. And the good thing is that that paste is still active. So right click, paste. The only thing I have to do is to take the thing out. So steel, I say problem 1. How about that? I forgot to say problem 1 in the other. Yeah, for the parts also. Yeah, problem 1. And say OK. Now let's go and check our folder to see what's in it right now. Well, we had the product. There's the product. It says problem 1. Analysis, I said problem 1. These two, I forgot to say problem 1. It's a good idea to do that. I will show you why in a second. You can do it through file save management. The alternative is to go to the part, to the assembly. Go to the assembly. I'm in assembly right now. You see that? Go to the part. This is the part, and change the name by saying properties, product, and just add problem 1 at the end. Ring. Okay, problem 1. Problem 1. And of course, down here also problem. I have a reason for doing this thing. I want to show you something in a minute. Okay, notice that these will change. It says problem 1. Oh my God. Some elements will be impacted. That's okay. That's fine. I'm sure the impact is not going to be for us to be concerned about. So here again, for this guy, where is that thing? Brass. Oh, wait a minute. Brass, yeah, right here. Right-click properties. You can do that now. Problem 1. Problem 1. I have a reason for doing this thing. Again, some properties will be impacted. Fine. Hopefully it's not going to be bad impact. Okay, let's go back to the assembly. We are in the assembly. Save everything. Okay, let's go to our folder. Oh, wait a minute. I don't like that. These did not change to problem 1. The very first time, if you had done it problem 1, it would have been problem 1 here. The only way to change it right now, is for you to go and do it as a save as. That's the only way. Okay? If I had not done that initial mistake, when I use the properties and I put down the very first time problem 1, that would not have happened. So at this point, you have no choice but to go to file save management, right click save as. Let's do that. File. Well, obviously we have to go there. File, save management. This is the guy. See that? This is open. Save as. I add my problem 1 here. Okay, save. Okay, and then do it again for the other guy. Let me see now. File. I could have done it simultaneously there. Save management. The brass one is right here. See that? It made the steel change. Okay. Save as. Problem 1. Very good. We say okay. You say okay. Let's check our folder now. Let's check our folder. You see, we not only have the original ones. I don't need this. In fact, if I wanted to, I may be able to delete it. But these things are also given problem 1 at the end. Okay. I'm reluctant to delete these, but I'll just leave it like this now. Now, why did I put problem 1 at the end of everything? Okay. We're going to come and finish the problem. We haven't done it yet. So, on the test, if you go to your Blackboard section, now you are currently, this is currently for section 53, but I'm going, oh, here, right, hang in there. Let me go to section 52. 52, right there. Because we haven't finished it for you guys yet. This is not you. You are not, this is 51 and 52. At the very bottom, now remember how you submit your homework? Right there. At the very bottom, it says midterm. Lab section 51, lab section 52. For you guys, it's going to be 53 and 54. So hypothetically, if you clicked on 53 and you were writing a test, it shows you question 1, question 2, question 3. So the things that you just did was problem 1. You're going to dump it in here. You don't see any GA names. You see problem 1, problem 2, problem 3. Just so that you don't get confused and the GA don't get confused, my product and my parts and analysis, at the very end of all, I said problem 1 so that you know where it's going to go. Okay? Let's go back. Any questions? You see why I was very fussy about doing these things? Are you alive? Oh, can you hear me? Yes. Okay, very good. Okay, very good. All right, let's go ahead. Now we saved our analysis. Everything is ready to go. Let's go to the analysis. I can double click on this, or I can go to generative shape design, generative structure analysis. Okay, let's start with restraints. So planar symmetry, surface slider. That guy and that guy and the bottom. This guy and this guy, and turn it around. This guy and this guy. And you say, okay. All right. Save it. Now, I'm not doing the top. On the other hand, if this was a long tube that you were shrink fitting inside of another long tube, then you would have to do surface solid on the top. But if these are thin discs, think about it like that, the top is free, the bottom is free. Okay, so don't worry about it. Now, on purpose, I'm going to run this thing for you. It's not done yet, but on purpose, I'm going to run it for you and see what happens. It's going to run, but let's see what it gives us. It's not going to bomb out. That's a good sign. Well, let's look at the deflection or deformation. There it is. I can animate it. Looks like nothing is happening. I might say, oh, wait a minute. So what's going on here? Well, let's plot the stress. Let's plot the stress down. 1 meter stress. 0. So it did run. It gave me 0 stress. What was my load? Where is my load here? Do I have a load? What do you say? No, I didn't apply anything. You're right. I didn't apply anything because the load here comes from that pressure fit, and I haven't done anything about it. I didn't say a word about that business of, these are fitted together, etc., etc. So I have to do that. First of all, let's deactivate this garbage because these are zero stresses. Okay, the garbage means that it's nothing, basically useless. Let's deactivate it. Deactivate. Okay. So how do these two parts load each other through interaction at that face, the two mating faces? So I need to create a connection between them. Remember, connection means that these two people are siblings. These two people are related. I don't know, are they cousins, are they siblings, are they, friends, etc. So the first thing to do is to create a connection between them. Remember, this doesn't mean they're connected to each other. They mean they're related to each other. So general analysis connection, this is the only one that you need to do for this course, and you can get away with doing all the problems that you want just with this top one. It says you need 2 things. Well, the first one, why don't we select the surface of this steel? For the second one, I need to select the surface of that brass that I just hit right there. Okay, so you selected both of them. We say, okay, we have created that connection, that relationship. Let me bring it in the front so that you can see it. Now, the connection is created here. If you like, you can give it a meaningful name, etc. And it's that dot there. Sometimes it's the dot, sometimes there's red stuff coming out. It all depends on your geometry. Previously, when we did this problem on Wednesday, on Tuesday together, remember that bearing shaft assembly? There were some red dots going from one end of the hole to the middle of the shaft. It's great, the connection. How it is, how it's going to look like color-wise, it depends on the nature of the geometry. Don't worry about it. Now that we define the relationship between them, we have to say, are they cousins? Are they brothers, sisters, etc.? So that's done with face-to-face connection. First one is a slider, and you have an idea probably, but we have never done it. Contact I did for you. We did one problem with contact, the first assembly problem that we did on Tuesday. A facet, I have done it for some other type of problem, was not assembly. I've done it with shells, okay? As a matter of fact, remember, on Tuesday when we did a problem together, the edge of the shaft and the edge of the hole, I created a connection between them and I made a facet. I called it, think about it as being welded together, which is a bad idea, okay? And let's hop over once. It says pressure fitting connection property. So it must have something to do with mine. So you click on it. It says, where's the connection? Where's the support? Well, the support is right here. I just created that. Those two faces, right? So you select it. It says, what is the radial interference? This is the radial interference. I wish they would say radial interference, but it says overlap. Half of the diametral interference, okay? The diameter of this brass piece was 0.002 bigger than the diameter of the hole, so the radial interference or the overlap is 0.001. How did it know this is the number? Because I did this problem for you, not for you, for your classmates at 8:30 this morning. Oh yeah, and I'll be doing it again at 1:30 for the rest of the people. Okay, good. And look at the icon, by the way. It looks like something stuck inside of something else, and there's these arrows here kind of indicating the pressure, etc. We say okay. Save it. Save the analysis. That's what we did. And run it. I didn't put any loads there, but this will be our load, because it pushes these things against each other. It's not our imagination that these things are taking longer, because problems are getting more complicated, okay? Elements are parabolic, they're small, we refine the mesh at the interface, they're nonlinear, contact problems, etc. So when you think about, people who do crash simulation or metal stamping, etc., and they make a run and it takes 2 days to complete, you understand what's going on. These are very, very elementary, simple problems. I'll give it a time, another couple of minutes, it'll finish. But sometimes you may be tempted to kill the job. If you killed the job, hopefully you saved your analysis, it's finished. Your analysis so that you don't have to go through whole shebang again. Now, let's look at the results. First of all, deformation. Deformation means what happens. Now, anything that I don't like, by the way, I can hide. These things I don't like, I'm going to hide. The restraint, I'm going to hide. Hide. The elements, these elements I don't like, I don't want, I'm going to hide. Just clean thing. And this connection, I'm going to hide too. Hide. Okay. Deformation. Change the scale. Remember, I reset it. So, oh, animate. Couple of things here. Your first reaction is, what the heck is all this stuff in the middle? What the heck is all this stuff? Well, these are internal elements to basically take care of the pressure fit or the contact, okay? You don't need to see those, so I can double click on this plot here, double click on this and say, hey, don't show me everything, just show me the mesh for the ring and just show me the mesh for the brass. Don't show me all those intermediate stuff that I don't want to see. It's important internally it's using it to do the calculation, but at least I don't see that garbage. Your second comment will be, wait a minute, what's all this gap? I mean, you put the brass and stuck it into that hole. Well, what is that? What is that gap happening there? Well, let me tell you this. Remember, when you put the brass inside of the steel, the brass gets compressed because it has a bigger diameter. And the steel is going to get pushed out. So the displacement of the points in the steel are outward. The displacement of the points in the brass is going to be inward. This goes out fatter. This gets in thinner. Well, I mean, CATIA multiplies these things by a factor of 1,000 so that you can see something on the screen. Otherwise, you can't see it. So in reality, if you want to see what happens exactly, don't use a scale factor of 375. Use a scale factor of 1. This is real life. The problem is that you animate, you can't see anything. It is moving, but it's moving so small, and you didn't magnify it that you can't see anything on the screen. So let's go back, put it back on the default. I mean, there. Now let's look at the one Mises. You can look at the deflection too, but I guarantee you, look at the deflection, they're all going to be very tiny. I mean, the whole what is that thing? The whole overlap was 0.001 inch. So deflections is going to be even smaller than that, which is fine. But in this problem, deflection doesn't tell us anything, but the stresses do. One Mises stress does. Click on it. And there we are. Let's change the rendering. Material shading. And there we are. I promised you, at the interface, there is a sudden jump. There is a sudden jump in the stress because the Young's modulus is different. Okay? That's why red goes to blue. Okay? This is why there is a discontinuity in stress, and to take these things for granted, these numbers, you've got to be very careful. But if we pretend that these are reliable, the stress for the steel, the red stuff, is 13,000 psi, which is about half of the yield strength of the material. So for this overlap of 0.001, in all likelihood, if we trust these numbers, neither this nor the brass are going to yield. I don't know what the yield strength of the brass is. We can check it out. But anyway, I don't anticipate that. But this is assuming that we trust these numbers, and I have absolutely no reason to trust them. You have to do a mesh conversion study to see if the mesh that you picked was reasonable, etc., etc., etc. But right now, just something. Verify your intuition. Don't quantify them based on these numbers. Yeah, so that's one thing I got. By the way, there's something here. It's called cutting plane. That you can cut this thing and look at the stress distribution inside. I mean, there's nothing fancy here. It's just that sometimes you may want to look at inside of the part and see how the stresses vary. Let me see if I can rotate this. Just a second. Let me see if I can move this thing here. Come on. See, I have my computer is coming to its knees now because you can see. You know, I'm sorry. You know what I should have done? Let's just take 1 minute and do this. Let's go back here, make these things linear. It'll go very quickly, and we can do all these graphics manipulations a lot easier. It's going to run a lot faster. Remember, when I had parabolic just a few seconds ago, this was 300. Now it's down to 5. And it's not only fastness, it's just that we can rotate these things a lot easier too. Done. Okay, so look at the stress. Okay, and look at the, see how easy it is. Let's do the cutting plane. And you can cut the object. You can cut the object and look at the stress distribution inside. There's nothing magic here, because in this particular problem, the stress distribution inside is exactly the stress distribution that you see on this face, but nothing magic. Okay, so are there any questions? Are we good? Well, it must be good. Okay, so I'm going to stop this. I'm going to stop the recording. And obviously, I'm going to kill the session. And I'm going to go to my office hour. And yeah, I'll be there. Bye. Have a good weekend.